Hello guys, welcome to my channel. This is Ehsan, and in today's video we're gonna look at the small signal model of this bipolar junction transistor. But before we get started, if you're new here, please give me a thumbs up, hit that subscribe button, and also notification bell, so whenever I upload a new video you'll be aware of it. Let's jump into it. Here, this is a bipolar junction transistor. This is the base. This is what we call it base. This is collector, and this is emitter. You have to be familiar with their names. And this is NPN transistor. We also have a PNP transistor. Okay, for NPN transistor, here I'm gonna draw a small signal model, and the reference of this video is of course the fundamentals of microelectronics by Behzad, Razavi. Here you have these base. Okay, this is the base, this is collector, and this is emitter. Okay, between these three nodes I'm gonna draw the small signal model. Between base and emitter we have a resistor, we call it R pi. Okay, and between the collector and emitter we have this dependent current source, GM-V pi. I'm gonna just write V pi in this regime. And where is V pi? V pi is actually here, the voltage across R pi, the voltage between base and emitter. So why I draw it in red? Because this V pi is variable in this small signal model, and these parameters R pi and GM are constant, and you had to calculate them by calculating the DC current of this device, which is I collector of this device. So I'm going to write the formulas related to these ones here. After you calculate the DC analysis for your circuit, you calculate I collector of this device, and once you find out what is the I collector for this device, for drawing the small signal model, you can calculate R pi by this formula: beta times Vt divided by I collector. What is beta? Beta is the ratio between the collector current and the base current, and Vt is approximately 25 millivolt. And here, how about the GM? GM is the transconductance of this amplifier, where we're gonna convert the voltage to current. So this is the ratio of I collector divided by Vt for this device. And also we have an early effect for the transistor. If we don't have an early effect, this is the complete small signal model for this device. This is a complete small signal model. Okay, without an early effect. Here we assume that the V early is equal to infinity. But if we have an early effect, you had to add another resistor to this small signal model. So here we have this GM-V pi, and here we have R pi, and the voltage is of course V pi, and this is emitter, this is base, and this is of course a collector. But you had to draw another resistor, which is RO, between the collector and the emitter of this device. Okay, and what is the formula related to RO? RO equals to voltage early divided by I collector. Again, you need I collector for calculating RO, and here V early is not equal to infinity, so we have an early effect for this small signal model. You had to keep this small signal model into your mind whenever you want to calculate the, for example, the gain of some amplifiers, some common emitter amplifiers. Okay, you have to somehow have it in your mind. There is a resistor between the base and the emitter. There is a dependent current, okay, depend to the V pi, GMV pi, and if we have an early effect, we have RO between collector and the emitter of this device. Okay, and just to recap this video, we have this NPN transistor, and for this NPN transistor, the small signal model without an early effect, I mean voltage early equals to infinity. This is a small signal model for that matter. And if we have an early effect, which means that voltage early is not equal to infinity, for example, voltage early equals to 25 volt, you had to add another resistor RO to the previous small signal model. And there is an interesting idea which I'm going to use it from the Razavi's book. Here, this is a PNP transistor. Okay, this is a PNP transistor, and we're going to use the same small signal model for this transistor, as long as you keep the polarities of this V pi from base to the emitter. Okay, the small signal model for PNP and NPN are just the same. Just notice this idea. If you place the plus sign of this V pi into the base, you had to draw the GMV pi current from collector to the emitter. That's the whole idea. That's the whole idea. Okay? Okay, so this is all for this video. I'm going to try to use some examples using these small signal models, because this is really critical for you to calculate the, for example, the input resistance of an amplifier, the output resistance of an amplifier. And once you calculate those resistance, you can simply calculate the small signal gain of that amplifier. Okay, that's all for this video. I hope you like it. If that's the case, please give me a thumbs up, and if you have any questions, let me know in the comment section. See you in the next video. Thanks for watching.